One-step equations. This will take technically 2 days, March 25th and 26th, but I'm going to do one video for it, just so we're kind of getting it done and out of the way. The goal is that we're going to make this foldable today. Yours is going to look slightly different than mine, but the same concept is still there. So in solving one-step equations, we are actually now going to solve for that variable. So before we were given expressions like x plus 5 equals 10. Well, now we're going to figure out, well, what is x? What can x be to make the statement true using one-step equations and using inverse operations. Okay? So in order to start this foldable, okay, you have to make sure you have a green foldable. Yours is going to be green. Okay? Make sure that you cut on the dotted lines and fold on the solid lines. Okay? So you're going to take a pair of scissors and you're going to cut on the dotted line. I know that's not dotted over there, but you're going to cut over there. Then you're going to cut on these little dotted lines. Okay? When you have cut and folded, you should have something like this. Okay? And then you just fold it over, and you should have your 4 flaps with our 4 operations. Okay? With our 4 operations that we have here, each one has an inverse operation, inverse meaning opposite. Okay? So when we talk about addition and subtraction, they are inverses of each other, meaning they cancel each other out. Okay? And with multiplication and division, they are opposites of each other because they cancel each other out. So they come in pairs. Okay? So first we're going to start with addition and subtraction. Okay? All right. Let's say you are given the problem x plus 5 equals 20. Let's say you're given this expression and they ask you to solve using inverse operations. Okay? We have to get x by itself. That's the goal, is to get x by itself alone. Okay? In order to do that, we have to use inverse operations. Okay? So what could I do here so that my 5 turns into a 0? You want to turn it into a 0 because that's inverse operations. Okay? In order to do that, I have positive 5. In order to turn it into 0, I want to subtract 5 from both sides. Now, you have to do it from both sides because whatever you do to one side, you have to do to the other side as well. So you have 5 minus 5, that's 0. It cancels out. And then we have 20 minus 5, that's going to be 15. So in this expression, if I bring everything down, we have x plus 0 equals 15. Any number plus 0 is always itself. That's the identity property of addition, so we have zeros there. So really, we can just put x equals 15. Now we're not done there. We are not done there. It's a good idea to check your work. Okay. So in order to check it, I'm going to plug in this 15 for x. So I'm going to do 15 plus 5, and let's see if that does equal 20. 15 plus 5, that's 20. 20 equals 20. Is that a true statement? Absolutely. So I'm going to put check mark. That's correct. All right, not too bad. With subtraction, okay, it says add the constant of both sides. Add the constant to both sides of the equal sign. Okay. So let's say you have y minus 13 equals 39. So we have negative 13 here. How do I turn a negative 13 or a minus 13 into 0? Well, if I'm on the negative side of the number line, I want to work my way to the right. Okay? So I want to add, we want to add the constant. 13 is our constant. Plus 13. We want to do it to both sides of the equal sign. So negative 13 plus 13, that cancels out to be 0. And we have 39 plus 13, that's going to be 52. And if we bring our y minus down, y minus 0 is going to be itself. Y minus any number minus 0 is going to be itself. So we have y equals 52. And again, we're not done there. We definitely want to check our work. So when we check our work, I'm going to plug in 52 for y at the top. So we have 52 minus 13 equals 39. Let's see if that's true. When I do subtraction here, and I'm going to have to borrow. So we do get 39 equals 39. Is that a true statement? Absolutely. So we put check mark. All right, the last two, multiplication and division. All right, So with the multiplication problem, you're going to divide both sides of the equal sign by the coefficient. Okay. Let's say we have the problem 9x equals 27. So in this case, in our problem, we have multiplication there. In order to cancel out multiplication, we want to divide. And you want to divide by the coefficient. And remember, 9 is our coefficient here. So we want to divide both sides by 9. So 9 divided by 9 is going to be 1. So that's going to be 1x equals 27 divided by 9 is going to be 3. Remember that 1 times any number is always itself. This is the identity property of multiplication. Okay. Notice that with even addition and subtraction, we wanted the identity property of addition. Okay, and with multiplication, we want the identity property of multiplication. So the idea is that we are getting zeros and ones. That's the idea, zeros and ones, because those are the identity properties. So that's our goal, is to get zeros and ones. So if you hear you want to get zeros and ones, because that's the identity properties. Okay. All right. So we have x equals 3. And again, we're not done there. It's always a good idea to check your work. Okay. So we definitely want to check it. We want to plug in 3 for x at the top. 9 times 3 equals 27. 9 times 3 is 27. Is 27 equals 27 a true statement? Absolutely. So our work is correct. All right. I believe the hardest one probably out of all these is going to be division. Okay. So for division, it says make sure your division is in a fraction form. That makes it the easiest to work with is when it's in fraction form. And you're going to multiply both sides of the equal side by the denominator. Okay. All right. Let's say we have m divided by 6 equals 12. So we have a division problem here, and our first step is to make sure that it's in fraction form. That's the first thing we want to make sure. So we want to turn this into a fraction, m divided by 6. And we just rewrite it, m divided by 6. Now it's in fraction form. Now, the opposite of division is multiplication, so we want to multiply both sides by the denominator. In this case, our denominator is 6. We want to multiply both sides by 6. Okay. When we kind of put this problem together, we have 6 over 1 truly, so we have 6 times m over 6 equals 12 times 6, which is going to, I'm going to leave it as 12 times 6 for now. All right. When we have this problem right here, we can actually cancel things out. We don't know what m is, so we're going to leave it alone, but I do have 6 divided by 6. Well, 6 divided by 6 is going to be 1. That's getting our ones part. So now we have 1m, and then 12 times 6. 6 times 2 is 12, 6, and then carry the 1. 6 times 1 is 6, plus 1 is 7, so m equals 72. Okay. Again, just to check our work, it's going to be a little smushed here, but that's okay. So we check our work, we're going to plug in 72 for m. So we have 72 divided by 6 equals 12. And if you do your long division, it's going to be 12. And is 12 equals 12 a correct math statement or a number sentence? Absolutely. So we're going to put check mark. So again, division is going to be the hardest part, and we're going to do a lot of practice problems with that. Okay. So we're going to take this foldable, you're going to glue it in your notebook. Okay. You're going to put glue on the back side here and glue it into your notebook. Okay. So for example, just to make sure that you see it, you're going to put glue on the back side and glue it into your notebook. You can glue it diagonally, you can glue it up and down. Either way, it's going to fit in your notebook. I made sure to slim it down so it fits in your notebook. Okay. All right. If you turn into your Eureka book, okay, we are going to work with lesson 26. Okay. And that's going to be on page 125. So we're going to be on page 125. You are not ripping this out. I repeat, do not tear out. Okay, I'll leave them right at the bottom. Do not tear out. Do not. We're just going to that page, 125. All right, so we're going to do a couple problems on here, probably maybe only 2. All right. This is for addition and subtraction. Okay, so I'm definitely want to do number 2, and then we're going to do number 6. Okay, number 2, find the solutions of the equation below algebraically, meaning using inverse operations. Check your answer. This is very important to check your answer. Okay, so we have n plus 14 equals 25. The operation that we have in front of us is addition. If I go back to my foldable, I have addition. What does it tell me to do when I have addition? It tells me to subtract the constant, from both sides of the equal sign. Okay, our constant in this case is going to be 14. Okay, so I want to cancel out that 14 by subtracting 14 from it. I want to get that 0. So I want to subtract 14 from both sides. So we have 0 equals, we have n plus 0 equals 25 minus 14, which is going to be 11. So at that, I'm going to rewrite it. N equals 11. That's our first step. Second step is to check our work. We're going to plug in 11 for n. So we have 11 plus 14 equals 25. 11 plus 14 happens to equal 25. Is 25 equals 25 a correct statement? Absolutely, so we are all set, so that works. So this is our answer, and then we checked our work. So you're looking for the answer, what is n, and then you also want to check your work. All right, number 6. Identify the mistake in the problem below, then correct the mistake. So again, not only are we identifying the mistake, we're also correcting it as well. Okay, so it says p minus n equals 34. Okay, no problem. We have our operation that's happening is subtraction. So again, when we look at our foldable subtraction, it says to add the constant to both sides of the equal sign. So we're looking to add that constant. In this case, our constant is 21 because that's the number by itself. All right. The next row says it's p minus 21 minus 21 equals 34 minus 21. Well, that doesn't look quite right. My foldable said I need to add the constant to both sides. Did we add the constant to both sides here? No, we subtracted. So we want to identify the mistake by circling that we subtracted instead of adding, which also means our answer is wrong. So that's our first step, is to identify the mistake. Our second is to correct the mistake. So if I was to redo the problem on the side, we have p minus 21 equals 34. And again, our foldable said to add that constant to both sides. So now we want to add our constant, which is 21, to both sides. So plus 21 plus 21. We get 0. P minus 0 equals 34 plus 21 is going to be 55. So we have P equals 55. And again, as always, you just want to make sure you double check your work. So if we were to check our work, we're going to plug in 55 for P. We're going to do 55 minus 21 equals 34. Let's see if that equals 34. And we subtract 21. 5 minus 1 is 4. 5 minus 2 is 3. So we have 34 equals 34. Is that a true math sentence? Absolutely. So that's all set. All right, that is for lesson 26. I now want to move on to lesson 27. All right, so now we're on lesson 27. All right, so we're on lesson 27 at the very top. We are on page 131, and again, do not tear out. We're on page 131. Do not tear it out. We're just working in it. All right, for this one, again, I only want to work with a couple of these. Let's do number 2, and we're going to do number 7. So number 2 says solve 12 equals x divided by 4 algebraically, then check your answer. So again, we're going to solve it and then check our answer as well. So I'm going to rewrite it over here. We have 12 equals x divided by 4. So it looks like we have a division problem here. So let's look at our foldable for division. It says to make sure the division is in fraction form. All right, it's in a fraction. Multiply both sides of the equal sign by the denominator. Okay, so our denominator in this case is going to be 4. So we want to multiply both sides by 4. So we're going to multiply by 4. And not just that, so we want to multiply the other side as well. So we know that 4 times 12 is going to be 48. We know that 4 divided by 4, because they're diagonal from each other, okay, because remember that's a 4 over 1. They cancel each other out to be a 1, so that's going to be 1x. So 48 equals 1x, or the same as 48 equals x, okay? So again, 48 equals x. And again, we want to check our work. So we want to plug in 48 into our equation. So we have 12 equals 48 over 4. And to do this, how many times does 4 go into 48? 4 goes into 4 one time, 4 goes into 8 two times. So we have 12 equals 12. Is that a true math sentence? Absolutely, so that's going to be right. So we want to box in our answer. All right, last part. Number 7, when solving equations algebraically, Megan and Meredith each got a different solution. Who is correct? Why did the other person not get the correct answer? Okay, so let's look at the problems here. We look at Megan. Looks like they have the same problem, y divided by 2 equals 4. So it looks like we have division, so let's look at our foldable for division just in case. It says to make sure it's in fraction form. So they're both in fraction form, so we're good. It says multiply both sides of the equal sign by the denominator. All right, so we're looking for our inverse operation of multiplication. Okay. If we look at Megan, Megan has y divided by 2 times 2 equals 4 times 2. Well, it looks like I did multiply both sides by the denominator, so that looks right so far. So the 2's cancel out, and 4 times 2 is 8, so we have y equals 8. All right, that looks good so far. Let's look at Meredith. Meredith did y divided by 2 equals 4 divided by 2. But my foldable said I need to multiply. Does that look like multiplication? It does not, so that's going to be wrong. So I know off the bat that Meredith is wrong. So who is correct? Okay, Megan is correct. Megan is correct. And it says, why did the other person not get the correct answer? So why was Meredith wrong? What did Meredith do that got her incorrect answer? Well, she divided both sides by 2 instead of multiplying both sides by 2. So Meredith divided both sides by 2 instead of multiplying. So again, we answered both questions in our problem that Megan is correct, and then Meredith divided both sides by 2 instead of multiplying. So that's why Meredith did not get the correct answer. All right, that's inverse operations for Miss Grant. If you have any questions, please feel free to ask her. Again, make sure you have your foldable and you completed the 2 pages, lesson 26, 27, and you did not tear out those pages. Okay, you just worked on them. All right, have a great rest of your day.